Hi, I'm Steve. I'm a software engineer at Zenly, and I'll be talking about our experience with running ScyllaDB on Google Cloud, the good parts and the bad parts, and hopefully you folks can learn one thing or two from our experience. Zenly is a mobile app that allows you to see what your friends are up to, pretty much obsoletes the "where are you" SMS that I'm sure everybody had once. We're based in Paris. And we've been using Scylla for about 2.5 years now. And in two and a half years, things changed quite a bit for us. We had a 10x increase in operations on Scylla. So these numbers are for all replicas, but we sized quite a bit. We went from around 270 nodes to 1,600. And we scaled the storage quite a bit as well, 4 times. The first thing we wanted to address was why not running Scylla on Google Kubernetes engine, because we are actually running the whole Zenly production on Google Kubernetes engine, save for Scylla. And there are some pros and cons to it. The first thing with pros is that you get the niceties of Google Kubernetes engine, auto repairs, you have the networking, that's actually really great. You have log management, rolling updates, pretty much painless Kubernetes management. But there's another side to it, which means that for all the niceties you get, let's say, for instance, auto upgrade, there's a darker side to it, which is anytime they need to upgrade the node, they will kill it and provision a new one with a new version, which means if you're running Scylla or any database for that matter, you're gonna lose nodes, which means you gotta do manual repairs and fix everything. Also, now you do, but nowadays, back in the days, you could not really control when that would happen. It was pretty much seamless, but because we had local data, that would mean maintenance, because we had to, the new node would go back up and then we had to repair, so not that good. Also, the network is kind of expensive because of Docker and Kubernetes. Basically, they manage like a whole array of IP table rules to do the routing, to do the network, and this has a cost. Also, you don't really leverage auto-scaling because every time the ring would change, that would mean repair and rebalance and everything. So there's no real point into having auto-scaling on the database. And also the CPU pinning, which is nowadays available, but back in the day wasn't. The CPU pinning is not really easy to manage when you have classical Kubernetes neighbors, which means that you want pods to be scheduled on a machine, so not really good. And then you say, you know what, we're just going to run Scylla by itself. And in that case, to us, it wasn't worth it to run it on Kubernetes, so we chose not to. The good side, though, is the network is really, really good. We had 2 major incidents. One of them was we were not the only ones, so all good, but everything works perfectly. We didn't have any problems whatsoever, although it's pretty expensive. So when you do multi-zone, multi-DC deployments across zone, be careful with that because it can go up quite a bit. As far as instance types go, we went from the custom standard 10-core machine to a 30 cores one. Basically more shards per core, which meant a better disk efficiency. So there's kind of a sweet spot. It depends on your workload, really. But to us, that was kind of the sweet spot that we figure. And then we're actually considering moving to newer instances, the C2 or N2. We haven't done the cost analysis yet, but to us, they look pretty promising. The way we configured them, though, was kind of that's pretty that's where we get spend the most time was configuring them and finding the sweet spot. And the one thing we found was that running local SSDs with RAID 0 was the higher throughput we can achieve. And the cool thing is that when a node goes down, you need to do maintenance. You just bring up a new node. Then you have to do a repair, but everything works fine. So there's no need to run net SSD. You get pretty much the raw performance of local SSD. We tried net SSD, but Scylla would just kill it, and it would just time out because of latency. We're running on Ubuntu. Nothing fancy so far. That said, there is a little twist with regard to the kernel, and we're running this Linux kernel version. And if you are running on Google Cloud, I would highly advise you to do that because there are some issues with NVMe controllers on newer kernels, and let's just say it's been a rough month when we had to debug that. So if you do run on Google Cloud, please make sure until it's fixed that you stay on this kernel. Also, I just want to thank Glober and the support team for their tremendous help because we couldn't have figured that out without them.